Okay, so this one is not in the standard form. You're not easily able to see what a, b, and c are. It is not in the ax squared plus bx plus c format. This one is called the factored form because when we look at it, you can see that it has a binomial. As a reminder, bi means two, nomial means terms. So this has got two terms times two terms. Sometimes it has a value other than 1 right in the front. So this is known as a times one of the factors times the other factor, okay, when we go through and solve. So when you have the factored form, the easiest thing that there is to do, unlike the last one where you can see what the y-intercept is immediately, this one you use the zero product property to find your x-intercepts. So that is what I'm going to start with. This one is the factored form. And I'm going to use the zero product property to figure out what my x-intercepts are. So essentially I'm saying that 2 times the quantity x plus 2 times the quantity x minus 2 is equal to 0. And therefore, let me make this bigger for you guys to see. And therefore, according to the zero product property, either this is equal to 0 or this is equal to 0. And then I solve for x in both of them. And I have an x-intercept of -2 and I have an x-intercept of +2. I can go ahead and plot those. There are my x-intercepts. Now, in order to see what the line of symmetry, what the vertex, and what the y-intercepts are, one way to do it, well, one way to figure out the y-intercept, we know that the value of x is equal to 0 when we find the y-intercept. So what we could do is we could take y equals 2 times x plus 2 and x minus 2 and substitute in my x equals 0 because when I find the y-intercept, x is equal to 0. So I'm going to have 2 times -2, which is going to be -8. So our y-intercept is equal to -8. Okay, and then I'm going to go through and find the vertex. In order to find the vertex from this, what I'm going to do is I'm going to put it into the standard form. So that means I'm going to need to multiply my x plus 2 and my x minus 2. I'm going to get that product and then multiply 2 by it. So I'm going to do the into standard form first. So I have 2 times x plus 2 and x minus 2. Okay, so my first term is going to be x squared. My second term is going to be -4. And then my little rainbow, I've got this is a 2x and this is a -2x. So a -2x and a +2x is going to be 0x. Okay, but I don't really have to write that 0x. That doesn't make a lot of sense. And don't forget, I still have that 2 that I need to multiply by. So I'm really going to have 2 times x squared minus 4. I'm going to have 2x squared minus 8. There is my standard form. And notice that my value of c is -8, just like my y-intercept. Okay, and when I find the line of symmetry, I'm going to have x equals the opposite of b divided by 2a, but I don't have a value of b. b is equal to 0. Well, 0 divided by anything is 0. So my line of symmetry is where x equals 0. So here's where x equals 0. Oh, and it turns out that my y-intercept is actually my vertex. So I don't need to go through and plug in 0 because I already have the vertex. Okay, so there's that one. Okay, on this one, I'm going to do the same method. I'm going to say that I'm going to use the zero product property, so I'm going to have x minus 3 equals 0, and I'm going to have x plus 1 equals 0. So x equals positive 3 and x equals negative 1. Positive 3 and negative 1. Okay, in order to find my line of symmetry, I need to go through and multiply this. When I multiply x minus 3 times x plus 1, I'm going to get x squared, that's minus 2x minus 3. Okay, when I find my line of symmetry, LOS, x equals the opposite of b divided by 2a. So that's going to be the opposite of negative 2 divided by 2 times 1. So positive 2 divided by 2 is going to be 1. So that tells me my line of symmetry is at x equals 1. I know that I'll find my vertex in a second. I can look at this and I see that I have the value of c already. So my y-intercept, I'll put it over here, is equal to negative 3. I know that if I have a point to the left of the line of symmetry, I have its mirror image to the right. So I can add another point right there. And then finally, I'm going to go ahead and take a moment and figure out the rest of my vertex. So I'm going to take y equals, actually what I could take is this, x minus 3 times x plus 1. I know that my input is going to be at 1, so I can substitute that in for the x and figure out what y is. It's a little bit different way that I showed in class. Hopefully it's a little easier. So I'm going to have y equals negative 2 times 2 is negative 4. So my y-intercept, I'm sorry, my not my y anything. My y-intercept was at negative 3. My vertex, on the other hand, is at 1 comma negative 4. And then we have enough information to complete our graph. Okay, and finally our last one. My x-intercepts are going to be at x minus 1 equals 0 and at x minus 4 equals 0. So I'm going to have x equals 1 and x equals 4. X equals 1 and x equals 4. Okay, I am going to figure out my y-intercept. I know when I find my y-intercept, x is equal to 0, so I can say y equals the opposite of 0 minus 1 times 0 minus 4. It's going to be the opposite of negative 1 times negative 4. So the opposite of negative 1 is positive 1 times negative 4 is negative 4. Okay, I can find my line of symmetry. That's going to be equal to x equals the opposite of b divided by 2a. But in order for me to figure out what b and a are, I have to turn this into the standard form. So I will scoot up my paper just to show the work part. The opposite. Okay, so I have this times this is going to give me x squared. And I have this times this, that's going to give me a positive 4. And then I'm going to have x times negative 4, that's negative 4. And another negative 1. Altogether, that's going to give me negative 5x. And I cannot forget that I had this in the problem. It says take the opposite of all that. So when I take the opposite of all of that, I'm going to have the opposite of x squared plus 5x minus 4. And that is my new equation. Oh, and look, my y-intercept is the same, right? So you can always do the y-intercept this way. Okay, so I'm figuring out the line of symmetry. X equals the opposite of b divided by 2a. Obviously, b is a positive 5, so the opposite of 5 divided by 2 times a is negative 1. Okay, so then I've got the line of symmetry is x equals negative 5 divided by negative 2, or positive 2.5. Okay, and I've actually already drawn in that line of symmetry at 2.5. So then I'm going to use my line of symmetry as my input, and I'm going to calculate my output. I can take my 2.5 and I can substitute it into my standard equation, my standard form of a quadratic, or I can go ahead and put it into the factored form. So I think I will just go ahead and put it into the factored form. So I'm going to have y equals the opposite of 2.5 minus 1 times 2.5 minus 4. And that's going to be the opposite of 1.5 times 2.5 minus 4 is going to be a negative 1.5. So I'm going to have the opposite of 1.5, which is negative 1.5, times negative 1.5. And that is going to be equal to, a negative times a negative is a positive, 1.5 times 1.5 is 2.25. Okay, so my vertex is located at 2.5, comma 2.25. Or 2.3 is fine, right? But anyway, there's my vertex. So I've already plotted it on here. And then I went ahead and drew my parabola.